Okay, so in last class, what we have understood, what is all about machine learning, and we understood AI, ML, and DL, right? In the same, we understood what is AI, we understood what is machine learning, and we understood deep learning. So, in short, if we I want to differentiate between these, this is the slide you can read that artificial intelligence is a superset where we can enable any computers to mimic human behaviors like recognizing patterns, object behaviors, speech recognition, like that, right? And in the machine learning, which is a subset of AI, it is it is a technique that gives power to the machine without being explicitly programmed, right? That what is that means that we won't program everything in the machine learning. We have some algorithms defined, and those algorithms will find patterns from the data and give output in the form of prediction or regression or classification, like that, right? But in the case of deep learning, it is totally a replica of human mind behavior, right? How mind perceives the data, how human mind perceive scenario and speeches. It works on that, right? So taking the fundamental of the human brain, we have created the concept of neural network, and using multi-layer neural network, we build deep neural networks, and those neural networks extract features from the given input data, right? And after extracting features, they are able to predict the future occurrence of any new unseen data, right? So in the case of machine learning, feature extraction was done by manual, right? But in the case of deep learning, it is totally done by your algorithm, deep learning algorithm, right? So this was the topic of last class. Let's begin with new thing like difference between AI, ML, and DL, right? So these are the differences, major differences of between among artificial intelligence and machine learning and deep learning. As you know that deep learning, machine learning is a superset, and artificial is a superset, and machine learning is a subset of artificial intelligence, and deep learning is further subset of machine learning and AI. So in this slide you can understand the difference, like in the first point they have defined the definition of machine learning, artificial intelligence, and deep learning. Slide is visible to you guys?
Yes.
Yes, sir.
Okay,
Yes, sir.
okay, okay. So in the second point, what is written over there, that this is a subset and all, this is the second point we already discussed. In the third point, what is written there? AI is computer algorithm which exhibit intelligence through decision making. We already understood that. ML is an AI algorithm which allows system to learn from data. This is already discussed. DL is a ML algorithm that uses deep, more than one layer neural network to analyze data and provide output accordingly. See, ANN is a part of machine learning, but CNN is a part of deep learning. Why? Because in ANN we have only one or maximum two layers between input and output, but in case of deep learning you can have various numerous uh, numerous layers between input and output, like numerous hidden layers. That's why it is called deep neural network, right? So this is the difference. We are making the use of multi-layer architecture of CNN, where you can have as many as hidden layers you want, right? According to your need. If you find that by using three layers only you can get maximum accuracy, then it's okay. But if you further increase the layers and you found that your model gives more better accuracy than previous one, then you can add further layers to your model, right? So this is the main difference, right? See, fourth point, what it is saying, such tree and much complex maths are involved in AI. See, AI is a superset. See, you have to make your machine to mimic the human behavior, and it's not easy task. So there will be highest complexity in case of AI, right? Understand by this that if you want your machine to sense something and act accordingly, so for that you definitely you are going to use ML and DL, right? So in case of AI, you are talking about whole project, right? Just understand by the example that AI is something that this is the total whole project you are going to build, right? And ML is a sub part of that particular project, or you can say a module of that particular project. Like if you are going to make a project for mimic the behavior of human mind or human behavior, then there will be definitely multiple tasks involved. Like you have to make machines to detect objects, you have to make machines to sense the data, you have to make machines to take the decisions like that, right? Accordingly, and in case of taking decision, after taking decision, you have to execute that particular action, right? So this is what the AI is. But in case of ML, in case of ML, we are saying that it can be a module of any particular project. Like if you are having AI project and what we said earlier, and in case of machine learning, you are going to train a machine on for first on detecting object, second on speech recognition, like that, right? As much as the functions your project are going to execute, those all independent functions are trained via machine learning, right? So this is the difference. So if you have any, if see in case of machine learning, there what is written over there. If you have a clear idea about logic involved in the behind and can visualize the complex functionalities like k-means, k-mean and all, right? See what it want to say. It want to say that if you have clear objective, right? What do you want to do? For example, if you want to do object detection, that is a single task, and that single task can be executed by machine learning algorithms only if you train your machine learning on that particular task, right? Like in our example, we have taken like cancer detection, right? Let's say ki we have to detect brain cancer or any cancer, right? So we have to train our machine learning model on the cancer data, right? Either it will be electronic health record, or either it will be a medical imaging, MRI or CT scan, right? So after feeding those data to the machine learning algorithm will try to infer some information from given data, and that inferred data, information will be used further for further tasks like prediction or classification. In our example case, it will be a classification task, right? We have to classify unseen image or unseen data according to learned rule by the ML, right? Now come to the DL part. If you are clear about the math involved in the don't have idea about the features, so you break and complex functionality into linear and okay. So ML and DL are not separate things; they are similar things, but only the difference is auto feature extraction are there. So by via using neural network architecture, we are able to we are able to draw a deep learning algorithm which automatically extract features from the data, right? So this is the one of the difference, right? Next difference is the aim is to basically increase chances of success and not accuracy, right? In case of AI, you are totally aimed for success rate, not accuracy rate. If you want AI for doing doing some task, that means you want success rate on that. You don't want accuracy. However, accuracy will be there. For example, if you are having some task, AI task, and you are getting lower accuracy, that means you are not having good AI. So AI is a wholesome technology where you want to check the success rate of your AI, that it is doing that or not, it is doing that or not. If some task is given to the AI, whether it is doing or not, it is not finding out that it is correctly doing or not, right? So in case of machine learning, the aim of the machine learning is to increase accuracy, not caring about the success ratio, right? Here accuracy means कि much uh, how how much accurate your model or ML is. For example, if you are making machine learning algorithm for classifying cancerous or non-cancerous tumor in the brain, then you will check the accuracy, right? Success ratio is totally dependent on the accuracy, right? So you are not bothering about success ratio, you are bothering about accuracy. If your system, if your ML is more accurate, that means your ML is good enough, right? And for different tasks, we have different KPIs, key performance indicators. Like in some cases we use accuracy parameter, in some cases we use dice score coefficient, in some cases we use mm, root square means, like that there are numerous KPIs we have to evaluate our machine learning algorithm. In case of DL, the aim is to attain the highest rank in terms of accuracy when it is trained with a large amount of data. See, this is the difference. Machine learning algorithm can be trained in less data, but deep learning algorithms needs huge amount of data, large amount of data. That's why deep learning algorithms are tough to implement, because you need more and more data. For example, for the same task, if you are using ML algorithm, you can, in case of ML, you can train your ML on, let's say, 10,000 instances of records, right? But in case of deep learning, if you want your deep learning to be most accurate, let's say 99% accurate, then you need 10 folds more data than ML algorithm. Let's say if you are using 10,000 instances in case of ML, then definitely for deep learning algorithm to for deep learning algorithm, you need to get, you need to give approx 10 fold, means 1 lakh instances of that particular data to the deep learning algorithm, so that it will get the same accuracy which we got from machine learning on 10,000 instances, right? See the differences. Understood, guys? This is the difference, that in case of machine learning, for the same accuracy level, deep learning algorithms need 10 folds or more than 10 folds data to train upon, right? After training on those data only, that DL can achieve that particular accuracy of ML, which ML got on 10,000 instances, right, guys? And next is the types of category. In terms of types of category, it has defined the differences. Like in case of AI, there are three broad categories we already discussed: artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. But in case of machine learning, there will be three types of learnings: supervised learning, unsupervised learning, or reinforcement learning, or you can say supervised machine learning, unsupervised machine learning, and reinforcement machine learning. Next, in case of DL, it is can be considered as neural network with a large number of parameters layers laying on in one of the four fundamental network architecture. Unsupervised pre-trained network is the networks which are already trained on some data, and you can use them directly without training again. This is also called transfer learning. You have heard this term, transfer learning. There are already trained model in the market which you can use free of cost if it is available for you. And if it is not available for you free of cost, that means you have to pay for those models. But right now there are numerous models available, pre-trained model available to use, and you have to use them free of cost. Only you need to cite those models in your article or your project, right? That's what they want. Next, convolutional neural network. Okay, we discussed recurrent neural network. These are all are different types of neural networks which have been created in the past for different purposes. Like convolutional neural network is best for image processing, right? Recurrent neural network is best for speech recognition, like that. Like, so this is also a difference according to type of the AI, ML, or DL. Now come to the efficiency part. In case of AI, the efficiency of AI is basically the efficiency provided by DL and ML. Obviously, because we are to implement any AI, we are definitely going to use any of machine learning or deep learning, right? So what the efficiency of AI is totally dependent on the efficiency of ML or DL models used by you for that particular task, right? Second, for in case of machine learning, less efficient than DL as it can't work for longer dimension and higher amount of data. Obviously, if as we are talking about the AI or machine learning or DL, as we know that these three are totally data centric. That means they learn from the data, and if the data is lesser, definitely the accuracy will be lesser, right? But if we say that it is less efficient, that doesn't mean that it can't get the accuracy of DL. It can get the accuracy of DL if you are going to train them on larger data. But in general, machine learning algorithms are trained on less data because the lack of availability of data, right? And in case of DL is more powerful than ML as it can easily work for larger set of data. Obviously, if you are giving large and larger data to the deep learning model, definitely it will perform better, right? Better than ML, and definitely efficiency will be increased. But in cost of computation power, you have to give more computation power because the computation required in DL is more complex than the computation required in machine learning. That's why that's why by investing the cost of computation, you can get the larger efficiency than ML in case of deep learning, right? Okay, and the last difference is example of AI. See, now come to the example. Example of AI applications includes Google's AI powered predictions, right? Ride sharing app like Uber, Lyft, commercial flights use an AI autopilot. Like, these are the basically basic examples of AI already developed by humans, right? But these are not the complete AI. These are the AI we build for a specific task. For example, like uh, like Uber ride sharing app. Uber is using AI for finding the nearest car around you. It will ask for your location, and according to your location it will find the nearest availability of any car, any Uber car, so that you need not to wait for longer time, right? In commercial flight, use an autopilot. This is the best example of AI, right? Sometimes when in the mid-air, when the flight is there, sometimes the pilots use autopilot function, right? For example, if he wants to take some break for lunch, or for toilet and all, it will use autopilot function. And autopilot function is a totally a computer program or computer AI which control whole flight functioning, right? All functioning of that particular flight. So it will check for its height, it will check for its uh, speed, it will check for everything required by a pilot, right? Every information required by a pilot is taken by AI autopilot, right? Now come to the example of machine learning algorithm. Anyway, we are going to discuss examples of these in forthcoming slides also. But let's say virtual personal assistant Siri, Alexa. You are using If you are using Apple phone, there will be a Siri. If you are using Amazon, there will be Alexa. If you are using Android phone, there will be a Google Assistant, right? So these all are the personal assistant ML applications. These all are the ML applications of AI, right? And email spam and malware filtering. You can you can see that all the advertisement mails are now come to the spam folder automatically, right? So this is why this has happened, because already Google used AI to filter the spam or malware mails in your mailbox. But for in some cases, like for newly created advertisement, it won't find them as a spam, and you need to declare it as a spam. If you don't want those mails, you need to declare it as a spam. And if once you declared the email as a spam, and in future if the same mail, similar kind of mail comes to your mailbox, your mailbox will automatically label them as a spam, and don't put them to your inbox, right? Now third is example of DL applications like sentiment based news aggregation, image analysis, captioning and generation. These all are the example of DL applications where you are going image analysis, right? For example, if you are using what is this that application, Snapchat, or I don't know, I forgot that application name, where you have multiple filters like dog filters. If you take your pictures, it will automatically find your eyes, nose, lips, and according to that it will put dog's nose and dog's ears to your image, right? So this is that is also a kind of DL application, right? There are many applications are there, like what we say, sentiment analysis is there, and the best example, auto labeling, or oh yes, in Google search there is a image based search also that uses deep learning models, right? So by using deep learning models, you can easily caption your images according to image analysis, right? Sentiment based analysis, fake news analysis, and all. There are numerous examples right now in the market, right? So this is the main. These are the main differences which basically comes up when we are going to find the differences between AI, DL, and ML. But in short, if we say that AI and ML and DL are the same thing, only difference is that that AI is a superset, ML is the subset of AI, and DL is the subset of ML, right? And in case of ML and DL, they are going to provide execution of a specific task, and by combining multiple specific tasks, you can develop a complete AI or semi-complete AI, right? So this is the main difference. Okay, so this till now we understood what is AI, what is machine learning, what is deep learning, differences between machine learning, deep learning, and AI. Now, I think you understood these 3 points. Now, come to the machine learning. So, because we are studying machine learning subject, so definitely we are going to emphasize on machine learning only, right? So what is machine learning? You can see in the slide that learning is any process by which a system improves performance from experiences. This statement is given by Herbert Simon, scientist, research science, ML scientist, very far back in 1970s around. And this is the basic, most fundamental definition of machine learning. Otherwise, machine learning, you can define a machine learning like that machine learning is an application of AI that provides system the ability to automatically learn and improve from experiences without being explicitly programmed. This is the main point. Without being explicitly programmed, definitely you are not going to the program. You are not going to program everything in in case of machine learning, right? You have some defined algorithm. You have some developed algorithm which are going to learn from the data, right? So the main thing is we are going to feed some data to the machine learning, and on processing those data via using some machine learning algorithm, it will infer some information from that. And when we say it will inform some information there, what it means, it directly means that it will find some relation among those data, between those data, and it will save those relation for future uses. For example, for classification purpose, for prediction purpose, for regression purpose, and all. Okay, so machine learning focuses on development of computer program that can access data and use it to learn for themselves. Here, learning means saving those patterns, saving those inferred information, saving those relations, right? Saving those interrelations between those particular data against given output, right? In case of supervised, and in case of unsupervised, there will be no output label, so it will automatically find out a cluster according to filtered images, according to filtered rules. It will classify different clusters of that particular data, so that humans can easily find a group of similar kind of data out of those inputted data, right? What is written there? The process of learning begins with observation or data. We already said that, such as example, direct experiences or instructions, in order to look for pattern in the data and make better predict decision in the future based on the example that we provided. See, this is what we have told right now. The primary aim is to allow the computer learn automatically without human intervention and assist and adjust actions accordingly. See, this is what the AI, the ML is. The aim of the ML will be to learn automatically without human intervention and provide assistance or adjust actions according to the learned rule or the inferred rule from the training data. When we are saying training data, that means the data we have given to that particular algorithm at the time of training. So this is the machine learning. Now come to the differences in traditional programming and machine learning. We already discussed in the past lecture that in traditional programming, what we were done that we have given data and respective program to computer, and computer uses that data and your program and give the output according to your program, right? This is the basic traditional programming fundamental, right? But in case of machine learning, this architecture has been redefined. Now we give computer the data and its corresponding output, right? And the computer will analyze the data and output and find a relation between the inputted data and the given output, and build some relation, or find some relation, or find the rules between them, and save those rules for future prediction. That means it is going to save those inferred information or inferred rules, so that next time whenever you are going to put new unseen data without any output label, it will simply automatically find that according to this given data the output will be this. For this data the label will be this, for this data label will be this, like that only, right? So this is the basic rule of machine learning algorithm, that it will train on the data and output, and after training we will evaluate, or we will use that trained model to for any specific purpose for which we have designed that particular ML. For example, if we designed that ML for detecting cancerous and non-cancerous tumor, definitely we are going to put data mixed data of cancerous and non-cancerous patients, and their corresponding labels to the algorithm at the time of training. After training, it learned what all the rules it learned from that data and output variable, it will use to predict for unseen data. Now after training, next time when we give them some new data for cancerous or non-cancerous patient, it need to identify that the given data is cancerous or non-cancerous. If it is identifying correctly that this data is given for cancerous and predicted value is cancerous, that means your ML is doing its task perfectly. But if it is not the case, that means there will be some problem, there are some problem in your trained model. That means you have trained your model in the wrong data, or or what we can say inaccurate data. So see, because machine learning is totally a data centric or data based algorithm. So if you are providing wrong data to it, definitely it is going to give you the wrong results. But if you are going correct data, proper data to the machine learning algorithms, it will give you a correct result definitely, right? So this is the our main focus, that before before training any machine learning model, you need to check that your data is clear enough, right enough, right? So that it will not misclassify or mispredict any data inputs in future, right? So this is the basic differences between traditional programming and machine learning. Next we have discussed basic example of machine learning, what machine learning are going to do under the need. Now come to the point, where do we use machine learning? Now we are talking about machine learning, what machine learning can do. Now come to the point that why machine learning, where you are going to use machine learning. Because for smaller tasks, for any task which needs smaller calculations, you don't need to implement machine learning. You can use direct rule based learning, right? Traditional programming, right? But in case there are many cases where you need machine learning. See the first point, machine learning is used where when human expertise doesn't exist. For example, navigating on Mars. See, you cannot go to the Mars and find patterns and find objects and analyze those objects in the Mars. So you created a hoverboard where you train that hoverboard for different tasks, for object detection, for analysis part, for soil analysis and all. So definitely if you are unable to go anywhere, definitely you are going to put some machinery or put some robots over there to do analysis part in place of you, right? That's why ML is needed in that cases, right? Human can't explain their expertise. See, in speech recognition point, humans cannot be expertise. See, they cannot they cannot just a minute. They cannot recognize every frequency coming from around coming from around, right? So they are not expert, they have don't have expertise because they have limited frequency range on which they can work. But or even they cannot differentiate between two people's voice and like that, right? Perfectly, I am not saying that they cannot, but they can. But in many cases they will misclassify between different species from coming from different person or different animals or different objects, right? So in that case ML is very useful, right? Next is model must be customized personal medicine. See, uh, whenever let's see, if somebody gets ill and a radiologist want to get some scans of that particular patient, and definitely the scanning, after getting those scan, that radiologist will tell that this is the problem. In some cases it is found that only 95% accuracy is there in case of humans at the time of scanning of radiology images like CT scan, MRI scan, there will be 5% chance of error. But in case of MLI, already we developed for that those particular tasks, we found that the error rate is far less than humans. If humans have 5% error rate, but our models already received about 99% accuracy. That means only 1% of error was there, we found, right? So it can be, ML can be a good add to the radiologist. So in case of see, what we are talking about, we are talking about a human life, right? If you misdiagnosed any human illness or sickness, definitely it is going to harm that particular person. So we don't want anyone to harm any human being by misclassifying or misdiagnosing that particular illness, right? That's why here machine learning can do some good tasks, like it can diagnose correctly or better than that particular radiologist, so that the chances of misdiagnosis or misclassification will be decreased, right? So that we can correctly diagnose that particular illness and correctly give the medicines or treatment to that particular patient, right? And the last is model are based on huge amount of data like genomic. See, genomic data is very high dimensional data. There can be millions of variables in the genomic data, right? So millions of variables cannot be observed correctly or cannot be analyzed correctly by humans alone. So in that case, where the large amount of data is involved, in that case machine learning can be a good source of technology that can analyze and process that data in less time, right? So in that case definitely ML is can be used. So these all are the cases, these are the some of the cases where ML can be used, right? So most of the time these all are the cases where we provide ML algorithms. Here in those cases our traditional algorithms cannot work perfectly because they are not built for large amount of data, right guys? So I think this is all for today. Thanks